Alright class, today we're going to talk about the unit circle. First we're going to do some quick review problems. 29 pi over 6, it's a positive angle, so we're going to go counterclockwise. And then I'm going to go in terms of pi, so that's 6, 6, 12, 18, 24. 30 would get me all the way to the next line, so we want to go right before that to 29 pi over 6. And then because of that, there's an extra pi over 6 we need to get to 30. So that's our reference. And the equivalence of 29 pi over 6, just type that in your calculator and you get 870 degrees. Again, multiply by 180, the fraction. And then negative 53 pi over 12. Again, we're going to go in terms of twelfths. So 12, 24, 36, 48. And then you have to figure out how many more we have. So 48 plus 12 is 60. We need 5 more. And since 6 more gives you a half, we don't need to go a full half. And because of that, the reference is the extra 5 that we went. And then you just do 53 divided by 12 times 180, and that's 795 degrees. Okay, so that's review. Now we're going to do some SOHCAHTOA. Alright, given a radius r and point xy, we can draw a reference triangle. So there's x, there's y. Sine is opposite over hypotenuse, which would be y over r here. Cosine would be adjacent to this angle. This is our reference angle. Theta. Cosine is x over r. And tangent is y over x, opposite over adjacent. Okay? Now, a unit circle is a circle that has a radius of 1. So, what that does, if you think about it again in terms of x, y, and theta, sine is just y over 1, which is just y. The cosine of theta is just the length in the x. And tangent is still y over x. So that's very useful because then we know that the sine of an angle and the cosine of an angle are always less than 1 because that's outside of the circle. They always should be. You should have known that from SOHCAHTOA anyway because the hypotenuse is always bigger than the adjacent or the opposite side. So we're going to use our special right triangles to actually use some properties. So first of all, if you remember from honors geometry, you guys were given a pattern like x, x, x root 2 or whatever. So I'm going to just write it without the letters, but just say 1, 1 root 2. But the problem is we don't want to use that reference triangle like that because the hypotenuse or the radius of the circle is root 2. So we want to divide by root 2 to get over here. So when I divide root 2 by root 2, I get a 1 here, and I get a 1 over root 2, which if I rationalize it, I get a root 2 over 2, and I get a root 2 over 2. These are very important numbers. Root 2 over 2 is a very important 45 number. It always will be the same for x and y, and it'll always be root 2 over 2. So the cosine and sine of 45 are root 2 over 2. Now, back in the day, you were given this triangle for a 30, 60, 90. Again, we want it so that the hypotenuse is 1 because we want it to be a unit circle. So if I divide everything by 2, this becomes 1, this becomes 1/2 across from the 30, and this becomes a root 3 over 2 across from the 60. So these are the other two numbers that are very important. Root 3 over 2 and 1/2 always go together for a 30, 60, and root 2 over 2s are the same, and they go with the 45s. So let's see how that works. So here's my reference angle. Here's my triangle. It's a 45 degree. We know this is 1. So we know the x is root 2 over 2 and the y is root 2 over 2. So this coordinate would be root 2 over 2, root 2 over 2. And that's at a 45 degree reference. So now if I told you I was at 135 degrees, that also has a 45 degree reference. And it's the same values. The only thing you have to be careful of is you have to figure out is anything negative now because we're in this quadrant. Well, we're now to the left of 0, so x is negative. Okay, for that point right there. For this point down here, both x and y are negative. And for this point down here, x is positive, y is negative. So that is that. For a 30 reference, 30 and 60 work the same way. 30 reference, the opposite side of the 30 is the 1/2, and the x value then would be the root 3 over 2 because it's longer. Always look for the longer versus shorter. So my x is root 3 over 2, my y is 1/2, or my sine. So my x's are my cosines. And these will all be the same for the same reference, except for, again, the signs. X is negative in quadrant 2. Over here, x and y are both negative. And over here, x is positive, y is negative. Okay? So those are the coordinates at 30 degrees. This would be 150, this is 210, and then this is 330. Alright, so 60 is the same thing as a 30 degree, except for it's flipped. Now, the short end is the x, so the x is the 1/2, and the long end is the y, so the y, or the sine, is root 3 over 2. So, I'm going to put that in there. I get negative 1/2 root 3 over 2, negative 1/2, negative root 3 over 2, 1/2, negative root 3 over 2. Okay, so that's all that. So now we're going to, so you can only do this at those certain angles that have references of either 30, 60, or 45. But you guys will have to memorize those eventually. So let's look at some problems. So first of all, we're going to do a unit circle. So I'm going to make a circle here, and I'm going to cheat a little bit. Actually, I am pretty impressed by that circle without doing what I'm going to do now. I have a tool that can change the shape to a circle. So it smooths it out a little bit. And then actually, I'm going to copy it. You guys could just draw circles on all these problems. This will just make it nicer looking. You know, the only thing I've got to do is center it. But it'll look nice, so. And we got one more down here. Alright. Again, I'm doing this because it's a unit circle, so I can do that. For the other ones, we weren't doing that. Alright, so this one's actually not as centered as I'd like. Alright, that looks a little bit better. Alright, so anyway, 225. Here's the beginning. 225, 180, 225 is here. That's 225. So we're doing what we did before. The reference is important. So if I draw this triangle, you should know that 180 to 225 is a 45 degree reference. And then if you remember correctly, the 45, 45, these are both the same length. They're both root 2 over 2. And then you have to figure out in what quadrant are we. We're in quadrant 3. So x and y are both negative. And that's all I want you to do. Just tell me the end point of that triangle. Okay, so let's do it again. Negative 150 is almost to 180 going backwards. I'm going to go here. So that's negative 150. The reference that's remaining is a 30. And again, you should just remember that you have two values. You have a 1/2 and a root 3 over 2. I just look at this and go, which one's bigger? The x is bigger. So the x is negative root 3 over 2. The y is negative 1/2. Again, they're both negative because they're in quadrant 3, so they're both negative. So yeah, let's keep going. 135 is about here. Again, that's a 45 degree reference. So this is a 45. So again, if I draw that triangle, 45, 45, it means both of them are the same. So all you have to really remember are these three numbers, root 2 over 2, 1/2, and root 3 over 2. And then again, y is positive, x is negative. Negative 300. So I go around and I have 60 degrees left. Oops. So my reference here would be a 60. So that's my reference. I should probably write the references down just so we have them. I wasn't really writing them, but we have to do that for the problem. There we go. Okay, so the reference is 60. Again, if I draw a triangle with a reference of 60, across from the 60 is the bigger side. So that means my y is root 3 over 2. My x is the shorter piece. That one's the 1/2. Okay? All right. Now we have that point. Let's answer this question down here. I want to know what the cosine of negative 300 is. Well, the cosine of a unit circle, or the cosine of this angle, is just the x-coordinate of that point. So the cosine of negative 300 is 1/2. You can type that in your calculator and see it for yourself, as long as you're in degree mode. The sine, or the y, at negative 300 is root 3 over 2. Now tangent is y over x, so it's root 3 over 2 divided by 1/2. So if you guys remember from our unit 3, you flip and multiply to solve this, and you're left with just a root 3 for tangent. And that's how you find tangent. You just take sine and divide it by cosine. And then you guys can learn, there are ones to memorize for that if you want. All right, so that is tangent. Okay, last one. Negative 90. So the reference is 90 degrees, but we don't have a triangle for 90. However, we don't need a triangle. This is a unit circle of a radius of 1. So you guys should know what this point is. We actually did it in that lab. Have we moved in the x direction at all? No. We moved down in the y direction. That's the point 0, negative 1. So now I want to know what the cosine at negative 90 is. The cosine is the x value. It's 0. We haven't moved in the x. And then the sine is negative 1, the biggest it can be, or I guess the smallest it can be. Now tangent is y over x. So negative 1 over 0. Can't have that. We say that tangent is actually undefined at this point. Undefined. Okay? So that's what you guys are doing today. And that is the unit circle. At the beginning of the unit circle, we'll just keep hammering these facts down so you guys got them.